Hey everyone, in this video I'm going to solve integration by a partial fraction question. It's an A-level question, past paper question, and this is the reference to that paper. Okay, so first of all, we have a partial fraction, right? We have a fraction that's 2x squared plus x plus 8 divided by 2x minus 1 x squared plus 2. It's going to be basically in the form of a divided by 2x minus 1 plus bx plus c divided by x squared plus 2. Now, why did I put bx plus c and why didn't I put a? I didn't put that because I have x to the power of 2. I have x squared basically here, right? So if it was not x squared plus 2 and if it was x plus 2, right, then I would have easily written b divided by x plus 2. But this is not the case. If you have x squared, then you're gonna write it as bx plus c on the numerator. So that's what you're gonna do. Okay, so if it was not x squared and if it was just x, then you could simply have written b instead of bx plus c. But right now we have x squared, so that's why our numerator over here will be bx plus c. So remember, so if you have a factor that is x squared term that has an x squared term, the numerator on top of it will be bx plus c, dx plus e, whatever it is, right? It depends on the, of course, fraction. And over here, we just have a simple x, right? Not x squared, right? So it's just 2x minus 1. So we are going to write it as a, right? The numerator. So now we're gonna solve it. So a multiplied by x, we're gonna solve this and this. Okay, we're gonna multiply this, both a and x squared. We're gonna multiply this both. So what we're gonna write, multiply both of these, and we're gonna add the both products, right? And that is basically, I'm gonna just write what it is. Okay, so what we have to do, so plus 2 plus bx plus c multiplied by 2x minus 1. Okay, now we need to understand that we have right now a denominator. Okay, the denominator for this is basically 2x, this factor and this factor, right? 2x minus 1 multiplied by x squared plus 2. That is going to be equals to 2x squared plus x plus 8 divided by the same denominator, right? That has the same factors, 2x minus 1 multiplied by x squared plus 2. So what we can do is that we can cancel this and we can cancel this. So we'll only be left with now the numerators, because this part, this side denominator and this side, both the right and left side's denominator are the same. So we can cancel them, right? Now what we're going to do is we're going to open the brackets, right? We're going to expand it and then we'll see ax squared plus 2a plus, okay, it is 2bx squared minus bx plus 2cx minus c equals to 2x squared plus x plus 8. So basically x squared, ax squared we have, 2b squared, x squared we have, so that is gonna be equals to a plus 2b, right, plus, now we're gonna write for x coefficient, we have x coefficient over here and we have x coefficient here, right? So that's gonna be 2c, right? So 2c minus b, okay? And now we only have the constants. They don't have any x, right? They're not a coefficient of x. These are the constants, this one, and yeah, 2a. They don't have any x term with it. So that is basically plus 2a and minus c, okay? That is going to be equals to 2x squared plus x plus 8. All right. So now we're gonna compare the coefficients, right? For x squared first. So x squared's coefficient over in the right hand side is 2, and the left hand side it's a plus 2b. So what we can do is that we can write this x squared, right? A plus 2b equals to 2x squared. All right. So we can get rid of this x squared and we can get rid of this x squared. So we'll be left with a plus 2b equals to 2. Similarly, we will do the same thing and we will find for this is 1 basically in the x coefficient, right? In the left side, the x coefficient is basically 2c minus b, okay? And in the right side, the x coefficient is basically only 1 that you can see. So it's going to be 1, okay? So 2c minus b equals to 1. Okay, so this step which I did here, I just wanted to show that how the x squares are getting cancelled out, all right? So you can even skip that step, but yeah, this is how it is, all right? So the coefficients are not coefficients, sorry, the constants are 2a minus c equals to 8. There's one constant term that is 8, right? So yeah, 2a minus c equals to 8. So these are the terms that are very important for us. But now what we can do is we need to find, we have three terms. We have a, we have b, and we have c, right? What we can do right now is basically we will have to find a or b or c. What would be the most easiest procedure right now would be a x squared plus 2 plus bx plus c multiplied by 2x minus 1 equals to 2x squared plus x plus 8. So right now what we can do is that we need to know one of the terms at least to find out b, c, or a. Which term would be easiest to remove? So you can see b and c are together. So what you can do is you can find a, but you'll have to remove B and C. In order to do that, we know that when you multiply products, right? If you multiply something with 0, it will be, of course, equals to 0, right? You don't want bx plus c, so that both b and x are being multiplied with something. So what if this term was equals to 0? Then this whole b and bx plus c will also be equals to 0, right? So the whole bx plus c will be equals to 0 then. So that's what we're going to do actually. We're going to make this term equals to 0 first. 2x, the one that bx plus c is going to be multiplied with. And if bx plus c is multiplied by 0, then it will become 0. So that's what we're going to do right now. So 2x minus 1 equals to 0. That's what we have right now. So what would be our x value right now? X equals to 1 over 2. Okay. So because we want this as 0. So if I put x2, okay, 2 multiplied by 1 over 2 minus 1, that's going to be equals to 0 only. So now this is 0. This is bx plus c. Okay, multiplied by 0, that's going to be 0 itself. All right. Now we have a 1 by 2 whole square plus 2, right? What is that going to be? Basically 2.25a. Okay. So what about these now? What we're going to do right now over here is, instead of x, we're going to just put 1 by 2, all right? So what we did over here is that we're making x equals to 1 by 2, sorry, and for all the x's, we're going to put 1 by 2. So 1 by 2 square plus 1 by 2, right? And I had a coefficient of 2 over there and plus 8. So this is going to be equals to 9, all right? So we have basically 2.25a equals to 9. A equals to 9 divided by 2.25. A equals to 4. Okay, so we have right now A equals to 4. So this formula, like this equation that we found before, we're going to use that right now. So we have A equals to 4 plus we have we need to find B. So 2B equals to 2. B equals to 2 minus 4 divided by 2, okay, because it's 2b, so divided by 2, b will equal to minus 1. Now we're left with c, so we have a equals to 4, b equals to minus 1, all right? Now we have to find c. So c will be, basically, we'll use this or that. We're going to use this now. So 2 multiplied by 4, which is a, okay? A is basically, so 2a minus c equals to 8. So 2 multiplied by 4 minus c is equals to 8 will be 8 minus 8 equals to c, right? That is c equals to 0. So you need to show this, all right? So these are your solutions, okay? A equals to 4, b equals to minus 1, and c equals to 0. Our question is to express it into partial fraction. So our first form that we have written was, if you remember, was a divided by 2x minus 1 plus bx plus c divided by x squared plus 2. Okay, so now what we can do is that the values of b, a, and c that we have found, right, these values, we can input those there. So we will have 4 divided by 2x minus 1 plus, okay, so now we have b as minus 1, okay, minus 1 x plus 0, c is 0, right? So 0 x squared plus 2. Our final answer would be in this form. So 4 divided by 2x minus 1 minus x divided by x squared plus 2. So this is the partial fraction. It's now f of x. Your f of x is now expressed in partial fractions. Okay? So now we have f of x, right? So f of x that we found is equals to 4 minus 2x minus 1 minus x divided by x squared plus 2, or what was it? Yeah, x squared plus 2. So we have that, and we're asked to integrate that, right? So it's written integral of f of x with limits 5 and 1. So we're asked to integrate that. That means we'll have to integrate this, right? We'll have to integrate this, the partial fractions that we found. We're going to integrate that. And that's the reason why they made us actually uh, to make f of x into, f of to partial fractions. So now what we can do is, this is going to be, there are two fractions here, right? We can write the integral as this. We can split it into, right, 4 and divided by 2x minus 1 minus integral of, because there are two fractions, so we can make the integral like this. All right, so you're splitting it. 5, this is also equals to that. All right, if it was plus, then it would be plus here. Okay, so x divided by x squared plus 2. Now there's dx here, right? I didn't write dx, so dx and dx. All right, so that is what you have splitted the integrals. All right, that's going to help you. Now we're going to start with the first one, that is 4 divided by 2x minus 1, 5, with 5 and 1 as the limits. So this is a constant, 4 is a constant, so get rid of that. You will have 5 and 1 divided by 2x minus 1. Okay, so this is the integral that you have right now. Same thing if you do, okay, so this is dx, okay? Now what would you do is, you need to know that the denominator has an x term, and there's a rule that if the denominator, the function, say g of x, okay, is in the denominator and its first derivative is in the numerator, right, then when you're integrating it, if you're integrating this fraction, okay, it's a fraction, right? Denominator and numerator is there. So when you're integrating this fraction, you will get ln g of x, okay, the function that is written in the uh, denominator. And remember that the numerator needs to have the first derivative of the function, right? And this is the first derivative of the function, and plus c. So this is one of the this is the way how you will solve fraction questions, partial fractions integration in A levels. All right. So 1 over 2x, right? So you can see if you differentiate the denominator to check the denominator of this thing, this fraction is 2x minus 1. So if you differentiate this, right, um the differential of this would be equals to if you differentiate this, you'll get 2. Okay, so the first derivative of 2, I'm just going to write that here. 1 minute, I'm just going to write that over here, first derivative. So that's so if we write ln, so the denominator, I mean, if 2x, the first derivative of 2x minus 1 is equals to 2. So if we write ln 2x minus 1, we are considering that the numerator has 2, right? So if the numerator has 2, what we can do is basically, we can make that the numerator to have 2. We had 1 basically. So if we are multiplying the numerator with 2, so what we can do, that the whole partial fraction that we have, the whole fraction that we have, we can multiply it by 1 by 2, right? Or divide it by 2 basically. So if we are dividing it by 2, means multiplying it by 1 by 2, then it will be basically like this, 1 by 2 ln 2x minus 1. Why did we do that? Because we didn't have, 1 second, I'll just write it in different color so that it's visible. So 1 by 2. because we did not have 1 over here. We didn't have 2 over here. We had 1, and we bought 2 in the numerator. We multiplied it by 2, so we'll have to divide it by 2 as well. So that's why we multiplied by 1 divided by 2. Okay, so now that's the reason why we wrote my 1 ln 2x multiplied by 1 by 2, which is also equals to ln 2x divided by 2, right? Outside the integral, we have 4, right? So that's going to be basically equals to 4. No, that's going to be basically equals to 4 divided by 2. That's 2 ln 2x minus 1. All right. We're going to do for the next integral that we have, which is x divided by x squared plus 2 dx, 5 and 1. Okay, so basically we'll have to, before that I missed this step, so we'll have to make it into 5 and 1, right? So that's going to be 2 ln 2 into 5 minus 1 minus 2 ln 2 into 1, that's 2 minus 1. That's going to be basically 0, all right, because 2 minus 1 is 1, ln 1 is equals to 0, so that's going to be 0. And this is ln 2 into 5 is 10, 10 minus 1 is 9, so ln 9, and you have 2 over here, okay? So keep this you keep it here, we'll need it later, okay? So this was one part of it. So we're coming to this right now. We're trying to do this. Now again, we have the denominator as, okay, x squared plus 2. So the first derivative of x squared plus 2 will be, 1 minute, will be equals to 2x, right? 2x. Now in this fraction, we have x. We don't have 2x. So again, what we're going to do is, if we write ln, if we write this as ln x squared plus 2, we are considering that the numerator has 2 2x. So we're going to multiply this with 2. So if we're multiplying this with 2, we'll have to divide this by 2 as well. So that's going to be basically dividing by 2 is also equivalent to multiplying it with 1 by 2, right? Same thing, if we're dividing something with 2 is also equals to multiplying it with 1 by 2. So you're multiplying this with 1 by 2, the whole thing. So that's the reason why we will write here 1 by 2 ln x squared plus 2. Okay, this is going to be the if you integrate to x plus x divided by x squared plus 2, that's going to be 1 by 2 ln x squared plus 2. Now the limits, we're going to apply the limits. That's going to be 5 and 1, right? That's going to be equals to, let's see, 1 by 2 ln 5 square plus 2 minus 1 by 2 ln 1 square plus 2. So that's going to be equals to 1 by 2 ln 25 plus 2, 27, minus 1 by 2 ln 3. Okay, fair enough. Now our question asks us to, let's see what our question asks us, then I'm going to come back to this part. It says that giving the answer in the form of ln c, where c is an integer. Alright, so our answer, okay, so we have basically this and this. And if you look in the beginning, it's going to be this integral which we have found, right? This one minus this, so it's going to be 2 ln 9 minus 0, which is 2 ln 9, minus this, alright? Okay, because we found 2 ln 9 for this one, and we found this one for x divided by x squared plus 2. So we're going to do that, we'll have to subtract it, right? So we're going to take this one. This was the first integral. This was the second integral. They both first was subtracted by the second one integral. So that's what we're going to do, right? So 2 ln 9 minus 0 will be 0, like 0 only. Then minus this thing, right? Minus 1 by 2 minus 1 by 2 ln 27 minus 1 by 3 ln 3. Now they're asking us, okay, now they're asking us to, we cannot just leave it like this. They're asking us to give our answer in the form of ln c, okay? That means we'll have to remove the coefficients, these coefficients, these coefficients, these coefficients, and make all of them into one ln form. So this is the form that is required basically. Alright. So that's what we're gonna try doing, right? We're gonna do right now. So now we have basically ln, okay. What is common in all of them? There is 9, there is 9 here, there is 27 here, and then there is 3 here. Now if you notice, 9 is equals to 3 to the power of 2. The base of all of them are can be 3, right? So 9 is equals to 3 to the power of 2. 27 is equals to 3 to the power of 3, and 3 is equals to 3 to the power of 1, right? So all of them have one thing in common, and that's the base, all right? So that's why instead of 9, you can write 3 to the power of 2, right? And 2 over here minus 1 by 2 ln. So instead of 27, write 3 to the power of 3, then minus 1 by, okay, oops, I wrote here 1 by 3, but it was supposed to be 2, 1 by 2, all right? So yeah, 1 by 2 ln 3 to the power of 1, okay? So now what we can do is, we know that these, right, are, now let's not consider this part, we're considering only the brackets right now, okay? So what you can do right now is that you can write ln, now you have 3 to the power of 3, we have 0.5 as the like 0.5 over here, we can make it a power of 3 to the power 3 to 27. This is 27, right? So we can make it as a power of that, right? So what we can do is that we can do this, basically multiply this with 1 by 2, okay? Basically, yeah, the power, we bring it down, right? Usually this, whatever power is there, we bring it down. So we can even take it up in the similar way, right? We can bring it to the basis power. So that will be basically multiplying with the uh making it as a power as well. So there is another power, that's 3. So multiplying with the existing power, that's 3 multiplied by 0.5 or 1 by 2. Okay, so now we have basically this. Okay, similarly we're gonna do the same thing here, ln 3. Okay, why did I write 1 by 2 here. Okay, so ln 3, 1 multiplied by 1 by 2, right? And that minus, let's see, we can do the same thing here as well, right? Ln 3 to raised to 2 multiplied by 2. So let's scroll down. So now what you have is basically ln 3 to 2 into 2, 4, and ln 3 to the, okay, minus bracket, okay, in the bracket you have 3 to the power of 3 by 2 and minus ln 3 to the power of 1 by 2. Alright, next step what we can do is, I'll just write it here first, that ln A minus ln B equals to ln A divided by B. We're gonna use this rule right now. Okay, so ln, we're gonna do 3 raised to 3 by 2 divided by 3 raised to 1 by 2. Alright, and that is basically going to be, if you know the laws of indices, right, it's gonna be basically 3 by 2 minus 1 by 2. Okay, why is this long bracket? Okay, yeah, so 1 by 2, that is gonna be 3 raised to 1. Basically we found out 3, okay, this is basically going to be ln 3 raised to 1, and ln 3 raised to 4 is there. This log rule only, or len rule only, right? So we have ln 3 raised to 4 minus ln 3 raised to 1. So we're going to write ln 3 raised to 4 divided by 3 raised to 1. We're going to do the same thing. Basically, 3 raised to 4 divided by 3 raised to 1 equals to 3 raised to 4 minus 1. That's going to be equals to 3 raised to 3. Alright. So that is equals to ln, okay, I'm writing this ln only, alright, so ln 3 raised to 3, okay, that means, what is 3 raised to 3? See, the question asked us to give in form of ln c, okay, so 3 raised to 3 is gonna be 27, so the answer will be ln 27, okay, and this is in the form of ln c. So this is your answer basically, this one. Thank you for watching. If you found this video helpful, please like and subscribe. Share this channel with your friends. Whatever topics you want me to solve questions on, uh, let me know and I'll try to do them for sure. And thank you for watching.